structure properties relationships for nanoporous polycyanurates and bare nanocomposites.
Good day, ladies and gentlemen. First of all, let me thank the organizers of this forum for this possibility to give a talk. And the title of my talk is Structure Properties Relationships for Nanoporous Polycyanurates and the Nanocomposites. And this work was fulfilled in a collaboration of Ukrainian and French scientists. So, thianate ester resins, it's a new, very fastly developing class of high-performance polymers with a unique combination of properties: resistance to aggressive media, high thermal stability, low water and moisture uptake, low dielectric constants, high glass transition temperature, high adhesion to different substrates, metals, composites, at high temperatures, higher than 250 degrees centigrade. And applications, different applications, adhesives, coatings, polymer matrices, resins for constructions, for carbon plastics, glass plastics, and so on, especially for aerospace structures and microelectronics. And THER now replaces conventional epoxy resins in high-performance applications because they are really better. So for thermostable, THER-based nanoporous fields, we recently developed several methods of generation of nanopores in these THER-based films, and they were you can see synthesis of THER networks in the presence of high boiling temperature porogens, phthalates. It's a high temperature synthesis, and we need high temperature resistant porogens to stay in the system during synthesis. Then from number 2 to number 4, synthesis of hybrid THER-based networks with polyepsilon caprolactone, followed by partial hydrolysis or thermolysis of PCl and extraction of fragments non-grafted to the network. Number 5 is synthesis of THER networks with incomplete conversion, followed by removal of the THER fragments non-grafted to the network. And final 6, producing of drag etching membranes by bombing of hybrid THER-based networks with PCl of polytetramethylene glycol by alpha particles and etching of drags form. So all these results were published in well-known polymer journals. And then today I will present you our very recent results on synthesis of nanoporous THER films using ionic liquids as porogens. Ionic liquids are applicable in polymer science as polymer additives like porogens, solvents, catalysts, plasticizers, lubricants, electrolytes, surfactant agents. And they have some also unique properties like negligible vapor pressure, high temperature stability, incombustibility, recyclability. So how we prepare the porous THER films using ionic liquids? The one was 1-heptyl-pyridinium tetrafluoroborate as ionic liquids, and try to show, no, this doesn't work. So thianate ester resin was polymerized in the presence of ionic liquid, and we have this high cross-link density network keeping inside ionic liquids, and after complete conversion of monomer into the polymer network, we removed ionic liquid by extraction. So it was high temperature synthesis, and the composition was 80-20, 70-30, 60-40 with ionic liquid. Then the structural characterization. So for gel fraction content, the theoretical and experimental values were very close. It means that there is no any chemical interaction between ionic liquid and monomer or polymer synthesized, and this ionic liquid can be completely removed from the network after this synthesis. Also in FTIR spectra, you can see that ionic liquid is removed, no traces of ionic liquid in the gel fraction. And in Zoll fraction, we can find ionic liquid and some traces of CER which was not grafted to the network. And this is a combination of SEM and EDX analysis. And you can see microphotos on the left. It's precursors, and on the right is nanoporous films. You can see a pores in the figures. And also EDX analysis shown also confirmed that ionic liquid was completely removed because no traces of boron or fluorine was found in the final polymer network after extraction of ionic liquids. Then the nanoporosity was characterized using two methods, DC-based thermoporometry and SEM analysis, and we found that they are in good agreement, and average pore diameter was between 45 and 60 nanometers, and pore size distribution was between 20 and 180 nanometers. Then it's surface characteristics, surface area increased, and total pore volume also increased with increasing of ionic liquid content in initial composition. Now about viscoelastic properties by DMTA method. What is interesting here is CER networks are well known as high modulus network, and in our case, addition of ionic liquid and introduction of pores even increased more elastic modulus, at least in the range, in the temperature range from minus 150 to plus 150 degrees centigrade. And glass transition temperature was found to be lower for the nanoporous, lower compared to the pure network, but higher compared to the precursor containing ionic liquid. Also the same conclusions we can do using results of DSC investigations. Thermal stability for all the samples was around 400 degrees centigrade. And now some information about nanocomposites, nanoporous nanocomposites of CER-POS films, polyhedral oligomeric silicious oxans. We used the same polymer network and other ionic liquid, and also epoxy cyclohexyl pores. And after the synthesis, we've got a hybrid organic inorganic network which contains in polymer network the organic junctions and inorganic junctions with high gel fraction content. Also, the microphotos show us good nanoporous, well-defined nanoporous structure. And we can also speak about dual nanoheterogeneity, because we have small nanoparticles of pores size from 1 to 3 nanometers. And we have nanopores between 45 and 60 nanometers. So it's like a dual nanoheterogeneity. Also, parameters for pore, average pore diameter between 45 and 95 nanometers. DEC results have shown that glass transition temperature for all the samples was quite high, and one sample, this the CER network with 0.025 weight percent of pores, very low amount of this nanofiller, led to the network, the formation of the network with glass transition temperature even higher than pure regular structure polycyanurate network. Also high thermal stability, higher around 400 degrees centigrade. And finally, gas transport properties. We checked some gases, permeability and selectivity by these nanoporous films. And the most interesting is that these films have shown high permeability for helium and high selectivity for helium. So this, at least these films can be used for separation of helium from gas mixtures. Finally, conclusions. So novel nanoporous film materials based on thermostable cells have been obtained by polycyclotrimerization of decyanated ester of bisphenol E in the presence of ionic liquids. Then increasing of the ionic liquid contents result in increasing pore diameters and broadening pore size distribution. High thermal stability was fixed, and the dual nanoheterogeneity as well, as I said before, and the CER-based membranes can be used for gas separation. Thank you very much.
Thank you for speaking. These questions.
Anything on mechanical properties of these membranes or catalytic properties?
We just I just shown some modulus, this DMTA method, dynamic mechanical thermal analysis. So quite good.
Yes, please. Next question.
Yes, so I actually saw the modules shown, but I'm still wondering why it increases.
What?
Modulus is increased compared to pure polymers when you use a liquid.
Water? What?
Modulus.
Modulus, yeah. It's also a surprise for us. You see, we will check again and analyze these results. We have no idea for the moment. Yes.
A few words about the gas separation, yeah? Can you demonstrate some results?
Yeah, okay. Like this?
Yes, please. This is gas transport properties, and this is what kind of gas? Helium. Yes. Okay. This is two gases. Thank you. What else? Questions? No questions? Thank you for speaker again. And